So this is a question from JEST 2022, and this question belongs to statistical mechanics. A very straightforward and very simple question from a two-level system in which the energy gap was given to be zero point 0.1 electron volt. So I have taken the ground state as 0 electron volt for the simplicity and the first excited state as 0.1 electron volt, so that the gap remains as given in the question, that is 0.1 electron volt. Okay, and the temperature with which this system is at equilibrium is at 600 Kelvin, and they have asked about the probability of this system being in the higher energy state, that is probability for 0.1 electron volt, and a conversion factor is also given. This will be very useful to simplify the calculation. Okay, so if I go by simply writing the partition function, so z will be equal to 1 plus e to the power minus beta into 0.1 electron volt. Okay, so this will be the partition function. And if I want to write the probability of the system being in 0.1 electron volt, so this will be equal to e to the power minus beta into 0.1 electron volt upon the partition function itself, 1 plus e to the power minus beta into 0.1 electron volt. So if I just multiply it by positive of this quantity to just make it simple, it will become 1 upon e to the power beta into 0.1 electron volt and plus 1. So this is the probability. Now I have to put this in terms of numbers. So beta, you know, is equal to 1 over kBt, right? And beta into, if I multiply here by 0.1 electron volt, I will multiply this side also 0.1 electron volt. Okay, and this is given that 1 electron volt is 11600 K. So I can write this as 0.1 into, so I want to convert this into Kelvin. So it will be 0.1600 and kb, which is the Boltzmann constant. So 1 electron volt is equal to this much K, I mean in Kelvin. So I can multiply 0.1 into, just a second, 0.1 into 11600. So this is the Kelvin and into kb. Okay, and upon this is kb into Kelvin, which is 600. So K is written here, K is written here. So kb and kb will be cancelled. So that is the benefit of writing this in Kelvin. And then 00 is cancelled. And when you calculate this number, that means beta into 0.1, you get something like 1.95. Okay, and this will make calculation very, very easy because calculators are allowed. It will be e to the power 1.95 and plus 1. Okay, then after this, if you do the calculation, so here it is 1.93. Okay, just do it using calculator, and when you calculate it, you get it equal to, I'm writing it directly, 1.1267. So actually this will fall between 0.1, the probability will fall between 0.1 and 0.2. Okay, so this is the correct option, and that is option A. Okay, so you can use calculator from here onwards. Just the concept, this concept is very important. You can remember this also. It was given in the question that 1 electron volt is equivalent to this much Kelvin. But please remember, don't directly put 1 electron volt equal to this much Kelvin, because this is energy and this is temperature. So obviously you have to multiply it by Boltzmann. constant. So that's why I have multiplied it, and then Boltzmann constant got cancelled. So this conversion is very, very important, just to avoid using Boltzmann constant. Boltzmann constant will be cancelled and you will get easy numbers. Okay. And after this, you can use calculators, obviously, and then this will be the correct option. Okay. So two level systems are very, very important. Many times you see questions on this. Magnetic systems, for magnetic systems also, to explain the magnetic theory, two level system is very, very important. And otherwise also, as in this case, you can see that two level systems are very, very important. And this is a canonical system because the temperature was constant. So this was a canonical system. Okay. Thank you so much.